Alright guys, we're on 0654 summer 2018, paper 6-1, question 6. Okay, first one, we've got a train track. That's exciting. Okay, you're being asked to make the drawing of a circuit diagram, and you're given the beginning of that. The reason for this, they're showing you a DC power supply, slightly different to a cell. Okay, and you're being asked to draw two things: one, an ammeter and a voltmeter. Ammeters are drawn in series, and what I've done as soon as I've seen that is I've drawn the symbol for an ammeter. Reason doing so is get the cognitive load, get the pressure on your brain as low as possible. Do the symbol as early on, that way you can just come back to it and refer to it, you don't need to worry. Like similar, we want a voltmeter. Okay, now what we have to do is really connect the lines here. Straight lines, people, use a ruler. Alright, do not draw these free hand, and you want the potential difference of the power supply, so you have to connect your voltmeter across the supply, and then an ammeter can be placed anywhere in series here. Okay, 2 marks, nice and simple. Alright, the student picks up, switches on the power supply and waits until the train is running at a steady speed. You measure the current, the potential difference, and the time. Okay, key point here, which we'll come back to, is it's the time that the train takes to go round the track once, not twice, not 10 times, but once. Okay, doing some meter reading, which you'll be used to by now. 10 divisions, 0.1 to 0.2, so therefore each one is 0.01. I've got 1, 2, that's 0.12. This case, again, 10 divisions, but in this case it's 2 to 4. Each one of those is 0.2, so therefore I'm going 2.2, 2.4, 2.6, and 2.8. Alright. Question's very specific, says to us you must write down your numbers to 2 significant figures. Alright, fortunately these guys are already 2 significant figures, so we can just simply write them down, 0.12, 2.8. However, my time is not to 2 significant figures, 11.82. Well, 11.82 is 4, 11.8 would be 3, 12 is 2. Okay, so we're looking at 12 on there, not 11.82. They give you an equation for the electrical energy supply. This is one that we know from our theory course. Okay, electrical energy supply is just the multiple of I times V. IV is the power, so IV times time. Okay, all you're doing is taking your I value, your V value, and your T value, multiplying them together, and getting an energy. Comes out 2 significant figures. Seeing as everyone else is doing 2, we'll go with that. 4.0 joules. Okay, then we're given another equation to use. All we're doing is really just using the data they've given us. 1.6 kilograms. We know T was 12 seconds, so all we have to do is 50 times 1.6 divided by 12 squared gives us 0.56. We're then asked to calculate an efficiency. Notice I'm keeping to 2 significant figures again. We're calculating kinetic energy, then we're calculating efficiency, and they tell you how to do that. Alright. 0.56, which is our kinetic energy. 4 was the energy that we calculated before. We get 14% to 2 significant figures. Now, obviously, this is not 100% efficient, so the follow-up question is asking us, why not? Well, remember, if you've ever played with a train set, which I'm sure some of you have, train sets don't just produce kinetic energy, they produce sound energy. You can hear them. There's also heating, all right, friction between the surface, or heating in the wires, and all of these are waste energies, and so therefore our system is never going to be 100% efficient. Lastly, how could we make this better? Again, try and stay away from things like use better equipment. Okay, really we want to think about how we could use the same equipment to do this thing better, and that's where we come back to my point about doing it once. Okay, we should repeat the experiment multiple times. Don't just let this thing go around the track one time. Could be that during the first occasion the motor might take a little bit of time to start up. There could be something on the track. You never know, okay? Repeat the experiment, calculate an average. Always something to be recommended anytime you're criticizing the experiment. Please, please, please do not suggest that you use better equipment.